Hello guys, Crazy Chekhov here. I wanted to show you my latest project. I built, also the target was built a very easy device for digital modes for people who are not so technically skilled, because this is always still a hassle to use digital modes with all this cut control and the levels of the sound cards and all these things. And my target was push one button, this device boots itself, turns on the radio and starts the program. In my case, most of the time I use this GS8 call and is ready. So I push one button, GS8 is loaded, turns on the radio. The radio can be controlled with cut control to the correct frequency. Or we are using, these boxes are built mainly for the Anytone 778 or the Retevis RT95. These are these mobile devices. I don't have this, but in my community lots of people have these devices, and I built this mostly for these people. So I built at the moment 3 boxes. They're all the same, and I will show you what is inside. So I will show you first how this is working. I have here my Digibox. This Digibox is connected to the FTM300, FTM300 to ISO. With this cable. This is on the back, and also the FTM300 gets the power through this box. So the box is powered on the back with this XT60 connectors. Here comes the current there, and here is the connection for the radio. For the FTM300 is connected here. So this device turns on the radio and can turn it off. And here this yellow connector is just a standard network cable. I had to solder my own cable for the ISO FTM300 because this connector is made for this for the Anytone 778 Retevis RT95. You can connect this device just with a network cable and it should work. So and I turn this on, push one button, you see a blue light, it starts the radio. You see I have here my frequency, what I'm using, and the device boots up. And when it's booted, it's loading. 1 second. So this device is booted and it loads GS8 core, and I can connect through Wi-Fi to this box. Also there is a Raspberry Pi 3A+, I will show you later. And this connects to my Wi-Fi, or the cool thing is it creates its own hotspot if there is no Wi-Fi available. So in an emergency case, let's say there is no electricity, my Wi-Fi route is not working, I can still connect to this access point with my phone. It would be a possibility, or laptop, tablet, any program what can open a browser and has the real VNC viewer. This is available for Android, Microsoft. This is like Anytone, Anydesk, Team Viewer, this type of program. And the software is based on the DigiPi image. I have version 173 from KM6LYW. He's making this great Raspberry Pi images with already installed digital modes, and I load by default GS8 core. This is what I'm doing. So when the Raspberry is booting, I'm loading GS8 core. But there is installed FLDigi VSGTX, so FT8 or Whisper. There is also a PET WinLink email client, or you can use TNC modes, APRS. Yeah. And connecting to the GS8 call, you can just click on with the browser here, and it's open the same window. But usability is better with this real VNC viewer, because you can use it quite easy with the phone or the tablet. It's really good working. So double click, right click is, for example, 2 fingers, and this is better usability than in the browser. So, and this is running now, and if I press on tune, the device is transmitting, and everything is working. I'm already this is standby mode. So I will show you now the technical parts, what is in this digital box. So here you have a transparent version. You can see this all better what is inside. So there is, I have my very cool, look at that, my finger. Raspberry Pi, I choose the 3A Plus, it's called the model 3A Plus. This is important because if you use a Raspberry Pi 4, for example, or also a 3B, it uses much more power. This is enough to work with FLDG or GS8 core. So 3A Plus or the Raspberry Pi 02. They are more or less the same devices from the performance, but I choose the bigger version because the heat distribution is a little bit better, in my opinion. And for stationary at home, this box, there is no need to make this box. I don't know if the box is half the size. I don't really care if it's 13 centimeter wide or 6 centimeter wide. So for me, it's easier to work with this little bit bigger Raspberry Pis. So you see here on the bottom, the Raspberry Pi is here down. Then on top is the Pi 4, it's called. This is a power management module. And what this is doing, he is controlling the power for the Raspberry Pi. It's similar than for a PC. You push this button, or in my case, you can this external button here. You push this button. The Pi 4 boots the Raspberry, also sending the startup signal. Also gives power to the Raspberry Pi, and when I push it again, only short, he's sending the signal to shut down to the Raspberry Pi, and only when he's shut it down properly, he's turning off the power. This was important because then you have a corrupt file system. Maybe if you just cut the power without this. But it also has this Pi. I really like this real-time clock with a battery buffer. So the time is correct. This is important for your GS8 core or VSGTX. The time is very critical. So he's saving the time, and the third thing what this does, it has a power, so DC converter. I'm not sure if it's a buck boost or only a buck, because you can connect from 12 to I think 35 volt or something to it, and with this buck converter is also making the 5 volt for the Raspberry Pi. So this is all built on this device. So there are three things: so power management, real-time clock, and also a DC converter. So I can use the same power also from the radio. This was for me important. So, and what else you need? You need a sound card. And I have quite good experience with this AIOC sound cards. Who built this? This guy is Kuppers, I think. This is really amazing, because what he done is it's similar than a Digirig Mobile. Digirig Mobile, there is a sound chip on it, but don't need any drivers. Then there is a hub chip on it, and a serial interface chip. Also 3 chips more or less on one board. This is the Digirig Mobile. And what he does, this guy, also you should look it up, he put everything, is making everything with one microcontroller. So there is only one chip on it. This saves space, and yeah, you can. There's also a serial board simulated on this microcontroller sound card, only mono, but we don't need stereo. Or on one chip. It's working quite good, but the output was a little bit low. Yeah, the noise is a little bit high, but it's really, so no, kudos to this guy. He did a fantastic job, especially with the software, that this is all working. But the only thing what is a disadvantage for me, because I have Windows 7, Windows 8 sometimes running on my machines, and there is no driver for this sound card. So if you plug this in a Windows 7, Windows 8 computer, is not he will not find any drivers. It needs Windows 10, 11, I think. This was what I found out. So on my Windows 7, 8 machines, it's not working. But in this case, not important, because it's running on Linux, and for this it's working fine. But what I did, this is a open hardware design, so I downloaded the schematics and routed everything new. Used in principle in more or less the same design from him. Just made the traces new. I also tried to improve the sound performance a little bit, and I added a op amp to get a little bit higher. Firstly, to protect the in and outputs of the microcontroller, and get a little bit higher output. Yeah. So it's an amplifier, more or less, small one. I mean, it's not makes miracles, but it's a little bit better. Sound quality is a little bit better. And of course, I needed to add a connector. I wanted to use a network connector to make it as simple as possible. Now I only have all things. I mean, it's written here where is what. TX, RX, for cut control, audio out, audio in. PTT and ground. There I also added a second connector. Yeah. So you can connect this. Here's my name, Crazy Chekhov. And you can just with a standard network cable connect it to this Anytone 778 Terry Davis RT95. So what are the same, more or less. So this sound card is here. You see it on the bottom here, connected with a cable. I found a cable with right angles to save some space. So this is working. And what I also added is a MOSFET. This is with test boards. Also I need to make a PCB with this. This is so hand soldered, a little bit not so nice. But what he's doing is just cutting the plus So always when the Raspberry Pi has power, the MOSFET connects the plus. It's important to connect the plus. You can't switch the minus, because the minus is connected with the sound card. The minus is always connected to the radio. So if you cut the minus, it's very dangerous. Then all the current runs through the sound card minus to the radio. So don't do this. If you build something like this, use a P-channel MOSFET to cut, also to control the plus. You need to switch the plus. Yeah, this is what it is. Sound card, a power management, and a MOSFET. This goes till, it's a very good small MOSFET, I think 50 ampere. I tried it for, 2 minutes on 50 watts, what I can make with this device. There is no problem, it's not even getting warm. I also built a box for my 7300, a smaller one, but this is based on with the 02. And the box is smaller because I not needed the sound cards. It's already built in with the ICOM and serial. But it's the same. There's a VT-Pi. Also this power management here exists for the 02, what is only half the size. And when I turn this on, the cool thing is you not need a MOSFET for the ICOM 7300, because you can turn the device on and off with the serial port. Just have to send, it stands in the manual, you must send, depending on the baud rate, some bytes, and then the turn on command, and then it's turning on. So I push this button, the Raspberry is booting. Now I need to wait a little bit, and he will turn on my 7300. 1 second, I will press on. I will stay. You can wait a little bit. What I wanted to. Let's wait. So now he's turning on, and of course you can send all commands, whatever you want. For example, I lock the wheel with serial with the cut command. This is the standard JS8 core frequency. I set the frequency, I set the mode automatically, or send it from the Raspberry, and everything is ready. Working also with HF. But JS8 core you can try with FM. This is also working. Of course not so good like a single sideband, but most people, there are not so many devices what can do single sideband on UHF. So why? Another reason to build this box is because it needs very less power. Also compared to a tablet. So I have a Microsoft Surface Pro 6, and I reduced also the CPU frequency, the maximum. I think I turned it down to 700 megahertz or something. So still, I did really everything what I could to reduce the power. And there is a program what measures it, because for the tablet it's hard to measure with this built-in battery. How you will measure the power consumption of a tablet? I can only rely on software. So my software shows me it needs minimum 5 watt, maybe 6 watt, about 6 watt. And this Raspberry Pi, I will show you here with this power supply. I connected this here with the cable, turn it on. I have 13 volt. When it's off, it needs, he's showing 0 amps. I measured it with my multimeter, it's 400 microamps. So it's below 1 milliamp, 400 microamps. It's also very good. And when I turn it on, You will see how much power. The last line, you see the power. So it goes up sometimes 2.5 watt, but I would say the average, I mean, we need to wait until he's booted up and loaded the GS8 core and everything. It's about 2 watts. So this is a third of this what my tablet needs. I mean, yeah, at the moment only a little bit more than 1 watt, but it will be around 2 watt average, I would say. Maybe a little bit less, I don't know. So, and yeah, if you want to save the most amount of power what you can, if you want to stay 24 hours online, if for emergency, then I don't have a better solution, because this needs 2 watts to run GS8 core. Of course, I need also my tablet or my phone to control the GS8 core, but yeah, this I only turn on when I need it. But most it's running for if you want to be on standby 24 hours, you not need a screen to see it. So this is the Digibox what I built. Maybe it inspires some people to make something similar. Yeah, this is it. Raspberry, Linux, power management, sound card, and a MOSFET. Yeah, one thing I forgot, sorry. Very important, when you turn this thing off, of course, you push this button, he's closing the program. There is a bug, unfortunately, in Digibox. He's just killing the process and not closing the program. And when you not close the program, the stuff is not saved what you received. So very important. So I'm closing I push the button, close the program, and yeah, and then I'm shutting down the Raspberry, and when the Raspberry is down, then the radio will be turned off. It's the same here. I'm pushing this button. He's shutting down, and at some point, power off, he's turning off the ICOM 7300 with serial commands just. This is really great. Also, kudos to ICOM. And what you also can do with this VTPy, you can make a schedule. And you can see, so I at the moment made a schedule of that my VTPys, also this on the 7300 and also the FTM 300, starts at 1 o'clock and turns off at 9 o'clock in the evening. So you can program this into these VTPys. And so at 1 o'clock, this Digibox starts by itself, and at 9 o'clock it turns off itself. So I have more or less a communication system running from 1 to 9 o'clock. I'm reachable there, and I don't have to do anything. I think this is quite good for emergency, because the less you have to do, the better. So this was it now. Sorry. Thank you guys, and see you in the next video.